So today let us look at few laws of exponents. And before we look at these laws, let us review some terms related to this. So if we have the power a to the power of m, a is called as the base, m is called as the exponent, and the entire expression is called power. So what does a tells us? The base tells us what is being multiplied. And what does the exponent tells us? M, the exponent. So the exponent tells us how many times the base is being multiplied. Now, for example, if we have 4 to the power of 3, that means the base 4 is being multiplied and it is being multiplied 3 times. And if we are asked to evaluate this power, evaluate means finding the value, so we will multiply and write the answer. So 4 4s are 16 and 16 4s are 64. Okay, so let us now look at the laws of exponents. These are some basic and important laws of exponents. So the first one is any number a. If I have any number and if it is raised to the power of 0, the answer is always going to be equal to 1, no matter how big or small a is. So it could be maybe 500 to the power of 0, that is going to be 1. Or if I have negative 5 to the power of 0, that also is going to be equal to 1. So any number to the power of 0 is always equal to 1. The next law is, if I have 1 and I raise it to any power m, now that answer is also going to be equal to 1. That m can be any number. If I have 1 to the power of 631, that's going to be 1. Any number, 1 is raised to the power of 18, that is also going to be 1. Okay, so 1 to the power of any number is equal to 1. Next, if we have two powers which have the same base a, so I have a to the power of m and this is being multiplied to a to the power of n. When we have two powers whose base are the same and they are being multiplied and they have different powers, then it is going to be the same base a and the powers are going to be added. So a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. The powers are added. Similarly, if I have same two powers with different exponents but same base and they are being divided, so a to the power of m divided by a to the power of n. Now this can be also written as a to the power of m divided by a to the power of n. So in this case the base will remain the same and the powers will be subtracted. Okay, so a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Now if we have a which is raised to a negative power, say a to the power of negative m. So here what will happen is we will be writing this as a positive power, but we will be writing the reciprocal of a. So the reciprocal means numerator becomes denominator and denominator becomes numerator. In this case we don't have a denominator, that is the denominator is 1. So this will be written as 1 divided by a to the power of m. So the power is written as positive by writing the reciprocal of the base. Okay, for example, if I have 3 to the power of minus 5, this will be 1 over 3 to the power of 5. Or if the example is like 2 to the power of say 7, this is raised to negative 2, this can be written as 7 divided by 2 to the power of positive 2. We write the reciprocal and write it as a positive power. The last exponent power law that we will see, okay, so that is a is raised to the power of m and that is raised to the power of n. So this can be written as a to the power of m and the powers will be multiplied, a to the power of m into n. For example, if I have 2 which is raised to the power of 2 and that power is raised to another power, say 3. So this can be written as 2 to the power of 2 multiplied by 3 which is 2 to the power of 6. So these are the few important laws of exponents.